Welcome back! Let's go ahead and get started talking about acidity and pH values. Now, when looking to explain what makes a solution acidic or basic and relating it to their pH values, something that often comes to mind is what we already know, right? A lot of us have heard the term acidic used before. For instance, if you drink a lot of orange juice, you're like, oh, that juice was so acidic, right? But what does that actually mean? Chemically speaking and biologically speaking, what is acidity? And how do we quantify acidity? Well, first we must start at the very base of quantifying acidity, and that is through pH values. So pH values, where the P stands for potential and the H stands for hydrogen. So pH basically represents potential of hydrogen. Now, what does this actually mean? To understand the term potential of hydrogen, let's revisit our friend water. Pure water can dissociate into its component molecules or ions, where we have one hydrogen ion and one hydroxide, or oxygen with a hydrogen ion. And the concentration of hydrogen ions with hydroxide ions are equal if we're talking about pure water. It's where they become unequal that we run into acidity and basic solutions. So when we are talking about acidity, what we are most interested in usually is the concentration of the hydrogen ion, since hydrogen ions participate in many biochemical reactions. So thinking about acidity and pH, it's the potential of this hydrogen that we are talking about. So acidity is the term we use that is directly related to pH. It indicates how much hydrogen or hydrogen ions are present in a solution. So, how do we measure acidity? We calculate the pH of a solution by finding the concentration of hydrogen ions in the solution and then taking the negative log of that concentration. So that means the more hydrogen ions in a solution, the lower the pH will be, and the more acidic the solution will be. See the relationship? So more hydrogen ions means higher acidity, means lower pH. Now, the opposite of acidity is what we call basic. The less hydrogen ions relative to the amount of hydroxide ions, the less acidic the solution, meaning the more basic the solution. So, the more hydroxide ions means the more basic the solution, meaning the lower the acidity of the solution, meaning the higher the pH. So for those of you that like to take screenshots of your notes, I'm just going to write out basically what I just said really quickly in a nice, neat format, where we have the higher our hydroxide ion concentration means the more basic the solution, meaning the less acidic the solution, meaning the higher the pH. So if you want to take a screenshot or copy this down in your notes, go ahead. So looking at specific values, right? We know if it's more or has a higher pH, then that means that it is less acidic. But what does higher mean? Well, the baseline number that people have chosen for pH being at a neutral level is 7. So if we have a pH of 7 in a solution, that means that solution is at a neutral stance. So we are dealing with likely distilled water, where the pH is perfectly neutral. But if the pH lowers below 7, then that solution is said to be acidic, where you are more acidic if you are a lower pH, meaning you have more hydrogen ions. And conversely, if we have a pH that's above 7, then you are more basic, meaning you have more hydroxide ions in the solution. So if you add an acid to a solution, the solution will become more acidic. Makes sense. And if you add a base to a solution, the solution will become more basic, meaning it raises the solution's pH. Now here's where things get interesting and we start seeing that bridge between chemistry and biology form in really fun ways, right? If we were to add an acid to water, the pH of that water would go from 7 down to 2. But here's the fun part. If we repeat the same thing in blood though, we see that the pH in the blood only changes 0.1, right? It drops from 7.4 only down to 7.3. Contrasting this with water, where the pH changes from 7 all the way down to 2, that's pretty astounding, especially considering both are liquid substances. So why is this? It's because of something called buffers. So the stability in pH is absolutely critical for cells to stay alive. Imagine you're drinking a bottle of orange juice, yum, and then being at risk of death every time you do because the acid in the orange juice would make your blood too acidic for you to live, right? Thank goodness that's not the case. And this is because cells are able to stabilize their pH. So you can enjoy some orange juice by using something in those cells called buffers. The internal pH of most living cells must remain close to a pH of 7 in order for that cell to stay alive. Buffers are substances that minimize changes in concentration to hydrogen and hydroxide ions in a solution, so they help keep things in balance. All right, time for our check-in questions. This is check-in number 22, so be very careful and make sure that you are answering number 22 on your assignment. Is the following solution acidic, basic, or neutral? Hint, don't overthink it. Number 23, would you expect the pH of this solution to be below, above, or equal to 7? Awesome work today! That concludes our discussion on acids, bases, and pH values.